Welcome to the third episode. As is the name of the podcast, we start with thinking about a problem or opportunity, which is the first episode for any topic. Then we build the product in the second episode, and on the third episode, we talk about how to scale a company using that product. We repeat the sequence of the nature of the episodes for all the topics that will be talked in this podcast. This is the third episode for the topic of a transmission electron microscope. The following episode will be actually the episode 1 for a new topic, which will be our hydrogen fuel-based automotive. But for now, today's topic is still a transmission electron microscope, and in this episode, we will talk about how to scale the product and the company that produces transmission electron microscope. If you want to understand how to develop a TEM in an industrial context and what to, for a high-level decision making, how to actually commercialize it into a viable product, please go and listen to the first or second episode of this series. The second episode talks more technical details on the transmission electron microscope, and the first episode contains the vision, the market segments, the overall business of transmission electron microscopy. And now, if you want to understand the general context of the business of microscopy and the competitors, and at a higher level, insights on the business of developing a transmission electron microscopy, this is a good episode. We'll talk about TEM not only from the perspective of a mechanical architect, which we did in the last episode, but we will talk it from the perspective of a CTO and a marketing executive. I am 900% certain that young accidental successes like Mark Zuckerberg or a very young Bill Gates did not understand words like scalability, profit margins, return on investment. If you look at most engineers who stay as engineers for decades within a particular discipline, they also don't care about why should they make the design modular or cheaper or smaller in size or any other thing that doesn't include a CAD software or making a program. That is why people who ask questions before taking up any work are considered a nuisance by their mates who have been doing the same thing for ages with no need for higher knowledge or understanding of why. If you are this person to the right who's confused by corporate jargon, please remember that the young Zuckerberg and Gates to the left also did not know these words. They did not know these words, at least when they started. They were just like you. They wanted to build that code. They wanted to make that design. They were dreaming of that product. Over the years, these young lads had to learn the jargon when they realized that those few thousands actually became their first million, but then that million had to be taken to the first billion. Now, getting to a million wasn't and isn't very difficult. Going from your million to 9 digits is where the struggle gets real. It is not only about innovation, but discipline, structure, ambitions, building a dependable network, vision, ideas, and a natural instinct to learn, and learn the things that you don't know. That is why you need to know what is a scalable product. It has to be made scalable from the very first sketch of its first building block. It is designed to efficiently handle increased demands in production usage or market expansion without requiring significant additional costs or modification. Such a product can grow with the business, adapting to larger volumes of customers, higher production rates, or expanded functionalities with minimal additional input. The key characteristics of scalable products are modular design, because scalable products often feature a modular design, allowing components or features to be added or removed or upgraded independently without affecting the overall architecture. This modularity facilitates easier updates and expansions. The second characteristic that scalable products include are automated processes in production and service delivery. Automation in production and service delivery can make scaling up more feasible by reducing the reliance on human labor and minimizing errors, thus maintaining the quality and efficiency as volume increases. And of course, the goal is to increase the volume, right? And number three is high demand potential. A scalable product typically has a broader appeal or serves a growing market. It ensures that as more resources are devoted to increasing output, there will be a market to consume the product. Number four is low incremental cost. The cost to produce each additional unit or serve one more customer decreases or remains stable as volume increases. This is crucial for maintaining profitability at higher scales. For tech products, especially digital platforms or services, having a robust infrastructure that can handle increased loads, such as more users or data, this is vital. This often revolves around using scalable cloud services or servers that can expand capacity as needed. A scalable product relies on a supply chain that can adjust quickly and efficiently to changes in production volume. This includes having reliable suppliers and manufacturers that can meet increased orders without delays. Overall, a scalable product is built with growth in mind. It allows companies to capitalize on increasing demand uh, without increases in costs, thereby optimizing profit margins as the business expands. Very easy, right? It's very easy to say, but it's so difficult. Now, here is where it gets tricky. Scalable products are tricky in my world because I am in the world of hardware. I'm in the world of extremely expensive, high demand, but extremely complex capital equipment. What are they? They are massively big and complex machines that are extremely high priced. So your transmission electron microscope is one example, but then my next episode will be about hydrogen fueled cars, automotives. I also am planning to make an episode on um, smart homes, but it is going to be more futuristic. That one where the smart homes is nothing but a machine, and people are living in it, and yeah. It's interesting to so those are capital equipment where you have a very large machine with various different systems in it, and various different components making those systems and subsystems. In my previous episodes, I explained it very, very detailed, but in general, if you look at the human body has various different systems: your cardiovascular system, your digestive system, your respiratory system, and then there are organs that make up that system, and then you have tissues that make up the organs, and then you have cells that make up those tissues, and then you have organelles that make up those cells, right? So your human body is a high value capital equipment if you can compare it to my machines that I talk about. So yeah, in my world and in the world of my audience, especially those who would want to have a business out of making a capital equipment, uh, yeah, you have some tricks there, you have some risks there, because a scalable business is the one that's designed to efficiently handle increased demands in production, usage, or market expansion without requiring significant additional cost or modification. Such a product can grow with the business, adapting to larger volumes of customers, higher production rates. But generally, scalable businesses are software companies, online education platforms, digital marketing agencies, e-commerce businesses. These companies can often grow their customer base and revenue with minimal additional costs for each new customer added or sale made, leading to a potentially high profit margins at scale. But the world of high-tech instruments, equipment, and vehicles, that's not exactly the same. It's not exactly easy to grow the customer base without adding additional effort into the product. It's a mechanical product. It deteriorates after all. Even if it runs for 10 years long without a single problem, which is already a dream, it will deteriorate. So yeah, it's going to be a fun episode today for those engineers who want to look further and it's a great episode for market analysts and technical scale professionals who want to explain certain decisions to their technical counterparts. It's a perfect episode, just like the perfect previous two, for CTOs and CEOs of scale ups and startups. I'm very certain that the executives of bigger corporations wouldn't mind listening to this podcast episode as a choir would to the preacher. But I told you at the intro episode itself, this isn't a university lecture. I'm not Khan Academy. I would make it fun for you. So let's prepare you for an interview. So if you are a CTO of the company that would make a product like TEM Gen Z, and this is the name of the product that I used in my first two episodes. So go watch them or listen to them. If you are a CTO of a company that would make a product like TEM Gen Z, what questions would you get on scalability? Or a market executive for TEM Gen Z, then what questions could you get and how to answer it? So that's gonna probably answer some of your questions on how to actually scale your business. That will answer your questions on how to scale your business in the world of capital equipment. So beautiful, right? It's absolutely magnificent. I am looking forward to it. This episode is going to be quite a ad hoc episode for me, in the sense that I would go off script quite a bit. I've gone off script in my previous episodes, but 90% of this episode would be just me improvising and thinking along. So that's going to be fun for me as well. In the first episode, you were thinking about the product. You were thinking about the market. You were thinking about your competitors. You were thinking about the various different concepts. You're thinking about what added value can you bring to a TEM, because TEM already exists. Then what else can you bring? So then you thought about a 6-axis stage, and you got some money from your investors. And now in the second episode, you built the product. You hired the right people. You got the right partners, the right suppliers. You somehow managed to keep your customers intact. You delivered. You friggin' delivered. Good for you. Good for you. And now in the third episode, you as a CTO, you cannot rest. You really cannot rest, because you need to work on the next thing and the next thing and the next thing. You need to now work on scaling up your business. That's what you need to work on, unless you want to sell your business. And even that is not so good. No, I mean, like, why would you give up on your baby? But I don't know. That's philosophical. Once again, that's just philosophical. So if you are a scale up or an SME or even a established organization who is in the world of capital equipment, you will benefit from this episode and from these questions. So as a CTO, your first question could be, what are the key technological challenges we need to overcome to scale the performance of TEM systems further on? My answer here would be miniaturization of components while maintaining precision. So you have to make the machine smaller, more compact, and more reliable as time passes on. So miniaturization of components while maintaining the precision, that's critical. And that is one of the challenges as well that's there to scale the performance of the system. But high vacuum systems and electron gun stability, they are generally the recurring challenges. And you will also have challenges in automating the alignment processes. So AI, in a way, I would just say that AI and machine learning is quite valuable in these alignment processes. So alignment processes, what is that? When you have a sample and you have the electron beam falling into you have the sample on the sample holder, and the sample holder takes it to the vacuum chamber, but then the stage can move in the six axis directions, in all the 6 axes. The alignment of how you will place the sample, that's a very difficult process, because the light will behave in a different way with different angles on the sample. And we talked about this in the first and second episode. So automating this alignment process, because I think most of it is done today manually. So automating this using machine learning process, it can reduce the setup time significantly and make it easier for the operator. And to be honest, it's more or less a software upgrade that also makes it a bit easier, because it makes it easier for the existing systems in the market already to be upgraded. High vacuum systems and electron gun stability are recurring challenges, as I mentioned. So redesigning the vacuum systems with more thoroughly researched materials and new metals, yeah, they could significantly influence the performance. By the way, the Thermo Fisher automated, I can give an example here. Thermo Fisher automated their TEM alignment with the Titan Creos already, and this reduced user intervention. So this is one of the examples of how changing certain things in, or changing a module, or changing a part, changing design can help overcome the challenges on scaling the performance of the TEM system. Next question is, how can we streamline the integration of hardware, software, and optics for faster production and higher reliability? Modular designs should be adopted wherever components like lenses, detectors, and softwares can be standardized. Cross-functional teams need to ensure that they are communicating, and communicating. That's all I would say to streamline the integration, commonality, and standardization of different components. That is absolutely very, very, very important to scale your business and to actually have a large number of customers at the end, because that's the goal. I can give you an example that exists today. Geol's microscope. You remember Geo from episode 1? They have modular designs, and it's very easy to upgrade and repair their components. I can also give you another example. Even ASML's modular designs. ASML is a semiconductor lithography equipment development company. All right. And one modular example is also your automobiles, your cars. When your car breaks down, when the brake system of your car breaks down, God forbid, you don't have to change everything. You can locate the problem and change the brake fluid, right? So how are they able to do it? Because the automotive industry has a very good streamlining process of the hardware, the software, and the overall optical parts that go into the car. What emerging technologies or materials should we consider integrating into our TEM systems to stay competitive? Wow. So graphene windows for sample holder, and machine learning based noise reduction in image processing is still there, but probably there are a few more steps to go. These are quite promising. Integrating cryogenic stages can address new markets like structural biology. The TEM that we already saw in the first 2 episodes, they already have cryogenic stages, and that's also an example of getting to new markets. And that's another reason why it needed a medical device certification, even though it's not technically a medical device. Cryo-EM is an example, and that is from Thermo Fisher again. Cryo-EM is one of those cryogenic stages that are used in TEM systems. What strategies can we use to optimize the scalability of our manufacturing process while maintaining precision and quality? If you implement digital strategies to optimize the scalability of manufacturing process, I can go on and on about it, but using Design for Six Sigma in your manufacturing process will truly help you optimize and scale your process. I'm not joking about it. You need statistical process control, you need control charts, you need good measurement system analysis in your production facilities, and get Gemba walks every day. These strategies are what will help to optimize the scalability of your manufacturing process. But I can give you an example which is outside the production as well, and that is Siemens have used digital twin approach, and that has improved their precision equipment manufacturing branch to a good extent, I would say. How do we Establish and maintain partnerships with suppliers for critical high precision components. Long-term contracts with key suppliers and invest in co-development projects to ensure mutual growth. Zeiss and ASML has very good partnership, and this partnership dates back all the way to 1980s actually. And the only way UV machines, extreme ultraviolet lithography equipment, lithography machines are possible is because Zeiss takes care of the lenses and ASML takes care of the machine part of it. Amazing, right? So yeah, that's one example that I have experienced and witnessed in front of me, where two companies have co-developed each other, and they have invested in each other's growth, and they have grown together. Innovation and IP. What approach should we take to protect our intellectual property while collaborating with universities and research institutions? Whoa. Joint patents and clear IP agreements upfront in collaboration contracts. That is extremely essential. My personal take on involving research institutions, academic research institutions and universities is caution, 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 and extreme caution, because academia is not industry and industry is not academia. There are fundamental differences in opinions as well as outlooks in life when it comes to people who are working in academia and people who are working in industry. Industry is all about making money and reaching the market on time. Academia is all about publishing research papers. At one point, you have to mutually work together, sure, but always do so with clear agreements upfront. Do not, as a startup, a lot of times you get into this. I've seen so many startups get into this intellectual property debates with academia because things were not discussed at the very beginning, but because people are so excited to start something, they're so excited to just begin the job that they don't even think about collaboration contracts. But make sure you do, and you will be successful. I can give you an example. IBM successfully collaborates with universities under strict IP agreements for AI research currently, actually. How do we balance innovation with the need to standardize certain product features for scalability? You have to establish a core platform with customizable modules for innovation while retaining scalability. These are the things that we discussed previously. So I can give you an example of Intel. Intel standardizes chip platforms while innovating in performance. So certain platforms you have. What investments should we prioritize in terms of infrastructure to scale production? Focus on precision tooling and clean room facilities, and this would help in high quality TEM components at least. And also, of course, partnering up with the right suppliers and development of those suppliers as well. ASML, for example, invests in clean room lithography for their EUV machines, and this ensures consistent quality. How do we attract and retain top-tier talent in mechanical, electrical, and software engineering specific to TEM domain? Well, offer competitive pay, foster a culture of innovation, hold technical conferences, partner up with universities, provide engineers the incentive to come up with new designs and new ideas, and recognize their efforts, provide a annual increase in their payment methods. One example would be Google. Google is notorious for its extreme work culture. It retains talents within R&D and marketing domains by providing a very good competitive pay. That's going to retain to a good extent. And beyond payment, I think beyond payment is when you really feel you need to recognize a person who is doing well. Recognition goes a long way, and that's just how it is. How do we ensure that our systems comply with international standards while scaling globally? Employ regulatory consultants and design systems with ISO standards like 9001 for quality management. That's just a very small example, but I can give you an example of medical device companies like GE Healthcare. They follow ISO and FDA standards to ensure compliance. Now, my questions will be for the marketing executive. How can we identify and prioritize market segments for scaling our business? That is where Design for Six Sigma comes in. I mentioned in my first episode as well as my second episode where tools like TRIZ, Kano analysis, and Puke matrix, they are very, very beneficial because they are very data driven. They're very beneficial to study the trends that are available in academia and various different biotech and nanotech sectors. In fact, these statistical tools are very beneficial for keeping track of different markets. So you have biotech, right? Equipment that are used to scan biological samples. That's biotech. But within biotech, you also have various different segments. You have research-based biotech companies, and then you have profit-based biotech companies, and then you have these academic biotech companies. So which market segment will you prioritize? I think your Puke matrix and your Kano analysis and your TRIZ will take you a long way into recognizing that and influencing your stakeholders and shareholders and your investors and the board of directors. What differentiators should we emphasize in our TEM systems to stand out from competitors? Focus on the ease of use, automation, and innovative features like real-time visualization. Thermo Fisher markets their EPU software as a differentiator for ease of use, and that's one of the examples of how they can stand out from their competitors. How can we leverage customer testimonials and case studies to strengthen our market presence? Well, the best way to do that is go to them and talk to the operators, talk to the end users properly, make them fill up feedback forms and actually talk to them and figure out what they really, really want to see change. Customers achieved, and one of the ways that you can, so when customers are complaining about your product, it's actually an opportunity for you they're actually your free market analysts. They are telling you what you can improve in the future and what to focus on when you're trying to scale the product and trying to scale the company in the market. So do leverage your customer testimonials, absolutely. And every time the customers are happy and they have made a breakthrough using your TEM system, do encourage them to share the success stories and mention you in academic conferences or in academic publications or wherever. I can give an example like Geol showcases academic publications citing their microscopes, their exact brand, etc. What marketing strategies would you recommend for increasing awareness in untapped markets? Well, partner with distributors in new regions and use targeted online campaigns for niche markets. Example is Leica microscope developer. Leica partners with local distributors to expand globally. So they really have distributors all over the world. How can we collaborate with universities, research institutions, and industrial players to create long-term relationships? What does customers want? Customers want a product that doesn't break, and customers want discounts. Loyal customers want discounts and quality. So, and this goes for all businesses. This is not only just capital equipment. It goes for all businesses. So I can give an example. FEI, which is now Thermo Fisher, built strong academic ties through grants and partnerships. What role do trade shows, conferences, and journals play in scaling our business? Using the trade shows for networking and demonstrating innovations is very common in the semiconductor industry as well as the automotive industry. So yes, absolutely. Be there, show yourself, and get the recognition that you deserve. And content marketing. How can we effectively use digital marketing channels? Well, run webinars, publish technical blogs, use LinkedIn, target researchers and engineers. And like example is Zeiss. Zeiss uses webinars for their microscopy solutions. There is this a company called Schaeffler. They even have these thick engineering manuals where these are basically mechanical engineering booklets where you can go and you can check various different standards used to design products. Things like that go a long way for digital and offline marketing. What kind of content is most impactful for targeting researchers and decision makers? White paper, detailed case studies, live demonstrations, example of Thermo Fisher's YouTube tutorials, that they're everywhere. Should we consider alternate revenue models to attract more customers? Yes, always offer maintenance subscriptions or leasing options to lower upfront costs. For example, Carl Zeiss offers flexible leasing for industrial microscopes. What pricing strategies can we implement to cater to both cost sensitive and premium markets? Well, the answer is very simple. Create tiered models, entry level systems for cost sensitive users, and premium systems with advanced future. Example of that is Geol offers basic TEMS for teaching labs and advanced ones for research. How can we establish strong feedback loops to ensure product evolution? Annual surveys and host user group meetings to gather feedback. Always visit your customers and always try to visit your end users of your customers and get insights from the end user directly. Leica, for example, organizes user events to understand customer needs. Come on. What role does after sales support and customer service play in building brand loyalty? Well, offer rapid on site service, do regular calibrations, include gauge R&R services, provide online troubleshooting options for your customers. Example of that would be Thermo Fisher's customer service portal boosts loyalty through efficient issue resolution. ASML, who is a semiconductor giant and holds a monopoly over the lithography equipment in the semiconductor market, leaves no stone unturned when a customer complains or a customer has problems with any of their machines. That's how you retain customers and you create brand loyalty. Thank you so much for watching this episode or listening to it, wherever you are, whichever media you're using. I'm Prashurya Bhardwaj, the host of Think, Build, and Scale, and this was your third and final episode for transmission electron microscope, which was our very first topic. The second topic, which might contain 3 episodes, may even be made into 4 episodes. I'm not sure yet. That episode topic is of a hydrogen fueled automotive. I want to focus on hydrogen fueled commercial automotives first, and then I will perhaps talk about hydrogen fueled heavy automotives like trucks and trains and other automotives like that. Later on, I have so many different ideas on capital equipment, but for now, thank you so much for watching. Please, if you aren't that interested in my podcast, but you know somebody who could benefit from it, somebody who wants to be a startup owner, who wants to be a founder, who wants to build their own business, who's already perhaps a scale up CTO or CEO, please refer my podcast to them so that they can benefit. I'm always ready for listening to feedback and knowing more about what my audience would like to see more. So please do write to me at prachurya.b@outlook.com. prachurya.b@outlook.com. You have been an amazing audience. Thank you so much for listening. I'm going to keep making these episodes. I don't expect my podcast to just become viral and famous and popular all at once, because I'm talking about really deep thoughts and deep technical matters here, and I take pride in my skills. And my goal is to reach out to people who need this knowledge, people who need to have an idea, have a predefined business plan or a predefined plan to have a good start to their entrepreneurial journey. So basically, I take pride in providing a ready to go business development plan and product development plan for entrepreneurs to go and start working on their own capital equipment company. Once again, I'm available as a fractional CTO for your scale up or your startup. We will have to discuss the details over a call. Thank you for listening. Thank you for watching. I'm going to see you in the next episode.